Hello, Matt here from chemistrystudent.com. In this video, we're going to look at heterolytic and homolytic bond fission. We're going to talk about what these terms actually mean, why bond fission is so important in organic chemistry, and how we can show both types of fission using curly arrows in organic mechanisms. Before we talk in detail about heterolytic and homolytic bond fission, it is important you are comfortable with covalent bonding. Covalent bonds are atomic bonds that form when two atoms share a pair of electrons. An atomic orbital from each atom overlaps and creates a new area of electron density between the two atoms. The positively charged nucleus of each atom is attracted to the negatively charged electron density, and this pulls the atoms closer together, creating a covalent bond. Covalent bonding is an example of atomic bonding as two atoms are held together. A lone pair of electrons refers to a pair of electrons in an outer atomic orbital of an atom that aren't involved in bonding. Recap done? Let's go! In order for reactions to occur in chemistry, bonds between atoms in reactants have to break. Bond breaking is referred to as fission. Homolytic fission and heterolytic fission specifically refer to the two possible ways a covalent bond between two atoms can break. Imagine two atoms, A and B, held together by a covalent bond. As the bond breaks, the bonding pair of electrons could be equally shared between the two atoms, and each atom ends up taking one of the electrons. This kind of bond breaking is called homolytic fission. Homo meaning same, as in the two species that were bonded end up with the same share of electrons from the bond. However, as the bond breaks, the bonding pair of electrons could also be unequally shared between the two atoms, and one atom can end up taking both the electrons, and the other none. This kind of bond breaking is called heterolytic fission. Hetero meaning different, as in the two species that were bonded end up with a different share of electrons from the bond. In organic chemistry, we represent the steps involved in reactions using mechanisms that show bonds being broken and formed between atoms. Curly arrows are used to show the direction electrons move in. A full arrowhead represents a pair of electrons. A half arrowhead represents a single electron. If we were to draw this bond breaking process out for homolytic fission, the electrons move from the bond, where they are to start with, to the two atoms. As the two electrons move independently of each other, we would draw two arrows with half arrowheads starting from the middle of the bond and ending pointing towards each atom. Each arrow represents one electron, and each atom now ends up with one unpaired electron from the bond. Unpaired electrons are high-energy things in chemistry, and the species that get formed here are very unstable as a result. We call them free radicals, and they are highly reactive. The unpaired electrons are shown as a large dot on each atom. For heterolytic fission, both electrons in the bonding pair, move from the bond to one of the bonded atoms. Using curly arrows, we would show this as an arrow starting from the middle of the bond, where both electrons are to start, with a full arrowhead pointing to the atom that takes the two electrons. The two electrons from the bond end up as a lone pair of electrons on the atom that takes them. As the covalent bond was formed by each atom sharing one electron, when the bond breaks and one of the atoms takes both electrons for itself, it is effectively taking the other atom's electron and gains an electron in the process, giving it a negative charge and making it a negatively charged ion. The other atom has basically lost this electron and ends up with a positive charge, a positively charged ion. When drawing out these curly arrows, it is really important to make sure the arrows start from where the electrons are at the beginning and end up pointing to where the electrons are moving to. When showing electrons moving from a bond, the arrows are always drawn starting from the middle of the bond. Try to be as clear and as neat as possible when drawing them out. Homolytic fission is quite rare in organic chemistry, and heterolytic fission is much more common. This is because to break a bond homolytically, the perfect amount of energy is needed. This energy can often be found in the form of ultraviolet, UV, light. Meaning to get a reaction started using homolytic fission, conditions of UV light are often required. This has been outlined in more detail in a separate video about free radical substitution. Check the links in the description below. So, to summarize, homolytic and heterolytic fission describe the breaking of a covalent bond between two atoms. In homolytic fission, each bonded atom takes one of the bonding electrons, ending up with an unpaired electron. Highly reactive species called free radicals are produced and can be recognized by the use of a large dot representing the unpaired electron. A precise amount of energy is needed to homolytically break a bond, sometimes available from ultraviolet light. In heterolytic fission, one of the bonded atoms takes the bonding pair of electrons and becomes a negatively charged ion with a lone pair of electrons. The other atom from the bond ends up as a positively charged ion. Most bonds in organic chemistry break this way. Curly arrows are drawn in mechanisms to represent electrons moving in reactions. A full arrowhead represents a pair of electrons, and a half arrowhead represents a single electron. Curly arrows are always drawn with the arrowhead pointing towards where the electrons are moving to. For homolytic fission, two curly arrows, each with a half arrowhead, go from the middle of the bond to each atom. For heterolytic fission, one curly arrow with a full arrowhead goes from the middle of the bond to one atom. I hope you found this video useful. Please check out other relevant videos in the links given in the description below, and visit chemistrystudent.com for free notes and revision materials.